Artificial intelligence for completing games has been around for a very long time, such as for chess and Go. However, most of these games have usually been deterministic in strategy and skill based, but Pokémon differs from these other games by having randomness and luck built directly into the game, as it has random number generators everywhere. Statistical physics can be used to describe this randomness by modeling battle sequences in microstates and outcome as macrostates. The Brock fight is the first gym leader that the player encounters. In this fight, Bulbasaur has 3 available moves: Leech Seed, which steals 1/32 of the opponent's HP on all successive turns, Growl, which reduces the opponent's attack, and Tackle, which deals a small amount of damage. Battles are run on Pieboy, a Python-based Game Boy emulator.
Through a visualization of our initial simulations where the player picks random moves each turn, we can get a general sense of what winning a battle requires. For example, in the bottom left chart circled in yellow, we can see that in battles of lane 30 to 35, which comprise of mostly winning games, there is a heavy preference towards Growl, indicating that early Growl usage is necessary. In the pink circles, we can see a spike in the use of Leech Seed around turns 15 to 17, which is when we expect Geodude to have fainted and Onix to have switched in, indicating that Leech Seeding Onix early on is also necessary to win.
Reinforcement learning is a type of machine learning that uses concepts of states and rewards to learn. The state would be considered as everything that's going on in terms of the battle or game or environment, and the reward would be some sort of value, often calculated with a reward function that describes how good that state is or how good that action was. And at each state, after learning a bunch, the agent can determine which action can maximize the reward.
We then found a reinforcement learning library called Gymnasium by OpenAI. One could write a custom game environment by writing event handlers that would say whether a given action was successful or not, and there's also spaces to specify actions and observations.
We used this Gymnasium environment to train a basic reinforcement learning model. The basic training loop worked like this. First, the agent would receive an observation. Based on whether or not this state, based on the observation, has been encountered before, it would pick either the best action or a random action if it doesn't quite know what to do. Then it would see whether or not that action led to the greatest reward. We used an epsilon of about 0.3%, which means that about 30% of the time it would pick a random action even if it thought there was a better action to further explore more possibilities. Ultimately, we reached a success rate of about 95%, where it would consistently win about 95% of games.
Just looking at the data from the random simulation in the AI model, we can see that the AI model has a much higher success rate than simply picking random moves. Looking at the green box in the bottom chart, we can see that the AI has found a golden ratio of sorts regarding move usage percentage, with Leech Seed being around 20% of the battle, Growl being 35%, and Tackle being the most at around 45%. Over on the right, there are comparisons of the average player HP per turn for various battle lengths of the random model and the AI model. The AI follows the general same trend as the simulation, but the AI is able to keep its average HP relatively higher due to a greater usage of Growl early on. The move usage distribution per turn is highlighted in the 2 line graphs in the middle. In the simulation chart, all the moves are favored equally as the move is chosen randomly, except for Leech Seed, which over time runs out of PP. On the other hand, we can see that the AI has found an optimal time to use each move, with Growl being favored early on and Tackle being favored later on when all the setup is done. While our simulation forced the player to use Leech Seed on turn 1 because we deemed it necessary, the AI actually favors Growl turn 1, which is something we hadn't considered. On the left, there are heat maps of the theoretical win rate of each game state, defined by player HP and total opponent HP, calculated using all the games we had. The win rate heat map calculated through the AI games generally match the heat map calculated through the simulation, which is good because it means that the AI isn't breaking the game. But it's interesting to note that the AI has seemingly explored more possibilities than the random simulation, as seen by the fewer empty or black game states in the eye due to the lack of constraint for the first move. The 2 graphs shown are 3D heat maps, similar to the 2D ones before, but with effective growls as a third dimension because we had established growl as an essential part of winning. The size of each point is also relative to the number of occurrences of each game state. In the simulation, it can be seen that generally, as there are more effective growls in play, there are greater winning games. However, in the AI visualization, there tend to be more occurrences where the game is 1 in 3 to 4 growls, indicating that the AI is optimizing for the length of the battle instead of straight spamming growl.
This research has many interesting implications. Firstly, strategies found could inform the strategies for human players when doing challenge runs and speedruns of this game and others. Additionally, as randomness is very common in the real world, these strategies could be applied to train other AIs that will have to perform in random situations. Finally, the data analysis techniques we use are very useful in our understanding of game theory.
Future steps could include exploring a possible neural network implementation to improve training speed and accuracy, exploring ways that data from the learning model can be used to inform successful non-artificial intelligence decision models, and expanding these strategies to more complex and unlucky environments, as we used a fairly simple battle to train our AI on.